So now I'd like to introduce Brandon. Brandon Keepers is an awesome software developer.
Not true.
Brandon is previously at a company called Ordered List, who built a lot of really cool apps, and apps like Gauges, Harmony app, which makes you or allows you to write really easy websites with a nice user interface. Gauges is a really cool alternative to Google Analytics. And SpeakerDeck, which is, maybe you've seen SpeakerDeck before for sharing slide presentations. I love SpeakerDeck. They're all some of my favorite applications. And they were acquired by GitHub last year, and so now Brandon's a GitHubber. And he's taking a lot of the awesome stuff he learned about building really fun applications to his new friends at GitHub. And the stories that I hear from him indicate that he really cares deeply about improving his own craft, introspecting his own code, and understanding why he thinks it sucks, and drawing lessons from that he can share with others. And so that's what I think this talk is all about today. And without further ado, I'd like to introduce Brandon Keepers to share with us.
Thanks. I'm going to hopefully try and convince you why Justin is wrong and that I'm not a great software developer. No, I'm actually, I'm one of those people that's kind of an eternal pessimist. Like, I'm never happy with the thing that I just did, even though it was the best thing that I've ever done. So you're going to hear a little bit about that quest today. I love this picture. This is a park in Hawaii, and the story about this park is that it used to be a landfill. And I'm not sure how long ago, maybe 10 or so years ago, they closed down the landfill and they built a park on top of it. And I think that this is actually kind of a perfect metaphor for our software. You know, we have this nice, pretty facade built on top of like 30 years of trash. So that's kind of how I feel about most of the systems that I work on and that I use. So, as Justin said, I work at GitHub. I've been there about 6 months. You can find me online as Beekeepers, both on GitHub and Twitter. So feel free to hit me up. I'd love your feedback or your insights, and I'd love to figure out ways that I could learn from you and you from me. So I am tired of writing bad code. I've been doing software development now for about 10 years. And as I mentioned, every system that I work on, when I get done with it, I'm never happy with the state that it's in. It always feels like, you know, when you start, it's clean and fresh and exciting, and you're doing all the right things, and then as you keep sprinkling sand on it, if you went to Zach's sand piles talk previously, eventually you have all this cruft that builds up, and you end up with a system that's no longer fun to work on. And I'm tired of that. I want to figure out a way to build software that I can enjoy working on as much on the last day of the project as I did on the first day. So a few of my coworkers and I have kind of been on this quest for the last year or so to figure out, why is our software bad? You know, we're all really smart and intelligent people. We're talented. We read. We learn from other people. But why do these systems continually evolve into this mess that we don't want to deal with? And one of the things that we've discovered is actually that the code that we're working on is talking to us. I love this quote from Kent Beck, Small Talk, Best Practice Patterns. Code doesn't lie. If you're not listening, you won't hear the truths that it tells. So one of the ways that code talks to us is by code smells. And smells are the surface indication that usually corresponds to some problem deeper in the system. The idea was initially introduced in Martin Fowler's book on refactoring. And it was introduced by Kent Beck, who helped co-author it. And they had these 22 code smells that were basically things that they identified that may indicate some kind of problem. And these smells are basically just heuristics. They suggest when to refactor and even what specific refactoring technique to use. So for example, one of those 22 smells that I've noticed is prevalent in the systems that I work on is this idea of divergent change. So it occurs when one class is commonly changed in different ways for different reasons. Any change to handle a variation should change a single class. And in this refactoring book, the strategy that it suggests for solving this code smell or for eliminating it is to identify everything that changes for a particular cause and use the extract class refactoring to put them all together. So that's kind of how, if you haven't read the refactoring book, I would suggest it. It's a good it's just a good guide to help you start to become aware of the ways that your code's trying to talk to you. But one of the important things to keep in mind is that the smells aren't inherently bad on their own. They're often an indicator of a problem rather than the problem themselves. So a lot of times, like, things smell and we don't know why. So for example, I just got back from Italy last week. My wife and I went on vacation, and we got home, our house stunk, which is not uncommon because we have 2 cats, and cats just stink. But we had people checking on them, change their litter box and all of that. And a couple days later, by Sunday, Monday, the house still stinks. We're trying to figure out why. Well, it turns out one of the cats decided to use this basket in the basement as its cat box while we were gone. So anyway, the smell was something indicating that something was wrong. Initially, we thought, well, we just had to clean their cat box, but it wasn't that. And so it sent us on this journey to figure out what actually was wrong. So our code that I've been working on smells in all of the ways that Martin Fowler talks about in that book. But I've also started to kind of notice some patterns for myself in the system. And those are the things I want to talk about today. There's 2 things that stick out to me as I'm working on these systems for the last couple of years that are kind of recurring themes. And one is my code smells when my unit tests are complex and slow. And also my code smells when it's too tightly coupled to a framework. It seems like every problem I run into, these are the 2 things that I notice right away. And by trying to optimize for these 2 things, because when we're doing software development, there's a million different things we could optimize for. But when I try and optimize for these 2 things, I'm starting to notice that I'm actually happier with the result. So I want to walk you through today kind of my thought process as I'm looking through some code for these 2 things. Let's start with unit tests being complex. Has anyone here done test-driven development? How many? All right. Who here likes test-driven development? Most of the same people. Good. So those that raise your hand know that as you start to practice test-driven development, as you get better at it, it quickly becomes a design process. And so kind of for those that haven't, to give you an insight of what this path or this journey into test-driven development looks like. Initially, you start writing tests. Well, first of all, you start writing tests because people said you should, and it's a good thing. And so you're like, okay, I'm going to go do this thing that they said is a good idea. But initially, your motivation really is to prevent regressions. You want to figure out, how can I make my code less brittle? And so that's kind of your main motivation to start with. And it is one of the nice side effects of test-driven development, by the way. Eventually, though, you start to realize that those tests that you wrote to prevent regressions also have the benefit of giving you confidence to change your system. So you wrote them initially to make sure that you weren't breaking things. Well, now they kind of act as this insurance policy to make sure that you don't break things in the future. And if you don't like the way that something looks, you can change it with some level of confidence. So, and then finally, after you've gotten comfortable with test-driven development, you start to realize that it actually is just a design practice. It encourages you to write better code. I feel like I'm to the point now where I get lost when I'm writing code without a test. I'll sit down and edit. Every once in a while I'll have like a weekend hack project. It's like, well, let's see what I can do with this framework or this technology. And I'll sit down and start working on it. It's like, what am I supposed to work on next? And the reason is I've gotten to the point now where the tests help drive the design or the implementation of what I'm trying to build. So before we go too much farther, I want to give you a warning. I'm going to use a massive amount of quotes from this book because it's an amazing book. I would highly recommend checking it out, Growing Object-Oriented Systems by Steve Freeman and Nat Price. It basically is going to kind of take you through some of the things that I talk about today in much more detail. They build out a kind of example system using tests to help refactor it as they go. And all the examples are in Java, but I found I don't do Java anymore, at least I haven't for 6 years. I made it sound like a drug. I don't do heroin anymore. I don't use Java recently because I don't have the need, but it was still just as practical. So the first quote from these guys, We find that the effort of writing a test first also gives us rapid feedback about the quality of our design ideas. Making code accessible for testing often drives it towards being cleaner and more modular. And this is probably one of the biggest benefits that I've felt recently in test-driven development, is as I'm starting to write the code, it gives me some insight into what's wrong with the code that I'm trying to test. Specifically, tests will tell us if an object is doing too much, not enough, or the wrong thing. So I want to talk about a few test smells that I've seen in my code recently, and then we'll walk through a couple examples of these. So the first is that an object has dependencies on several other objects. So if I'm trying to test something and I have to do a whole bunch of setup to get it in the state where I can test it, and there's several other objects or classes that thing depends on, it makes me start to question, well, why does it depend on those things? Does it really need those to do its work? So those are called collaborators. But why are those important for this to accomplish its goal? Another thing that starts to smell is when I see a test case with too many assertions. So in this, I mean one specific case. I don't mean an entire file. So if I set up a test and I call some method and then I make 5 or 6 assertions about what that method does, I start to ask myself, well, why is this method doing so much? Is it changing state in too many ways? Does it have too many effects throughout the entire system? I also start to look at duplication in my tests. We're always worried about keeping duplication out of our application code, but very often we don't ask ourselves why our tests are duplicated. One pattern you'll see is you'll have a whole test case that does some setup, and then a bunch of, or you have one test that has a bunch of setup, and then a bunch of test cases inside of that use that same setup. And that to me doesn't bother me. It's when I see multiple tests throughout a system all with the same setup. So for example, in the GitHub code base, everything depends on a repository, right? So almost everything GitHub does uses a repository and both a record in the database and a repository on disk. So and then along with that, everything has to have an owner, a user to go along with that, and then we actually have to create the Git repository on disk to perform a lot of the tests. So it makes me start to question, well, why do I have to do this setup for everything in the entire system? Maybe there should be something that abstracts that concept so that I'm not having to continually set up repositories so that I can do these tests. And then lastly, and this has become more common for me lately, is if I open up a test file and it's not immediately obvious what that test is doing, it makes me wonder what the code it's testing is doing and why that's not immediately obvious. Again, from Goose, it's called Growing Object-Oriented Software with Tests. Poor quality tests can slow down development to a crawl, and the poor internal quality of the system being tested will result in poor quality tests. So the unfortunate thing is that this is kind of a negative feedback loop, and I think that the people that have been burned by test-driven development in the past, this is why. Because you start testing code that's poorly structured, and you write bad tests for that, and then that encourages you to write more poorly structured code. And I don't have any great insight into how to break that cycle, besides just to be very, very aware of it, and hopefully apply some of the things we talk about here. So let's look at a few examples. If a test is complex, the subject under test may be too tightly coupled to the rest of the system. I've been working lately on redoing GitHub notifications. So anytime there's any activity around a repository, we have a web interface where you can see what that activity is, and then we also have email notifications that you get. And so one of the first things I started to do was, well, let's clean up the email messages, because right now there's all this code in one big class that generates the email messages, and it's kind of a mess. So I want to pull them out into these simple classes that their only responsibility is to generate the content of the message. So I started writing a test for it, like a good programmer should. And so I'm testing, and this is Ruby, by the way. Is anyone who here knows Ruby? Few people? Okay. Hopefully, I think this code should be simple enough that you can at least recognize what's going on here. But this is a test case. So we have context context here sets up our test case. Then inside of it, we have 2 tests. We want to test that the to method uses the user's global email address, And then we want to test that the body includes the body of the comment that's coming through. So really simple. In the first one with the global email, I have one setup thing where I actually set that global email. Hopefully soon we'll have the ability where you can specify different email addresses for different organizations that you're a part of. So I do that setup and I make my assertion. So this is usually how I start writing a test. I start with the behavior I want to assert, and I do that before I have anything else set up. So then I say, okay, what is it going to take for me to set up this object in order to actually get this test to execute and pass? As I worked through it, it turned out the setup for this looked like this. And it had to do with the way that the system was currently designed. So in this setup block, first I have to create the thing that I'm commenting on. So I say issue.make, which kind of sets some default attributes on this issue and gives it back to me as just an in-memory object. I have a couple other lines of code that I don't even really know what they're doing. We have like these notification roll-up summaries that we create so if there's multiple comments on the same issue, we don't want to show those to you twice in the web interface, so they'll all roll up into one. So I had to do all that. I have handlers, there's an email handler and a web handler, and I don't know why I need them in this test case, but apparently I did. And again, the handler takes multiple objects. Finally here I have settings. I set settings to a new instance. I passed it the ID 1. I was talking with Justin Searles yesterday, and he said that actually was really confusing because what does 1 represent? And I know that 1 is a user ID, but it's not obvious in this test case, so make a mental note that I should probably fix that. But anyway, I finally have my settings object, which is something that I do need in this test. And then lastly, I have my message, which is the class that's under test. So when we find a feature that's difficult to test, we don't ask ourselves how to test it, but also why. And that was kind of after I got this test passing, which I did go ahead and do. I got all this setup done, implemented it, made the test pass, and I said, okay, well, why is that setup block so ugly? What can I do to clean that up? So I went back and looked at the code, and it turned out those 3 lines that I just talked through, I had no idea why they were there, why the system needed it in order to just generate the content of an email message. And so I started looking at how I could remove them. And I won't show you the actual implementation, but the code that I ended up with was a lot cleaner. It started to look like this. So now my only dependencies are the thing that's being commented on and the settings for the user that this is going to. So this made a lot more sense to me. Now I was able to remove unnecessary dependencies, remove coupling within the system. So the next example, if a test is complex, the subject under test may be doing too much. So in our last example, it wasn't that the email message was really doing too much. It had a pretty clear responsibility. It just had too many dependencies in the system. Now let's look at an example of something that's doing too much. And this is the idea of cohesion. So an element's cohesion is a measure of whether its responsibilities form a meaningful unit. Think of a machine that washes both clothes and dishes. It's unlikely to do both well. I love that image because it's hard to get concrete images like that when we're working on code, but when you actually think about a machine that washes clothes and dishes, it would be chaos. So another way of putting this is the single responsibility principle. And that's basically that every class should have a single responsibility, and that responsibility should be entirely encapsulated by the class. And so that's this has kind of been a really important principle for me in the last years I've been going on this journey, is every time I'm looking at a piece of code, I'm asking myself, why or what exactly is this doing? What are the responsibilities this class has? And again, from Goose, an awesome way to test that is our heuristic should be that we should be able to describe what an object does without using any conjunctions, without using and or. And this is really hard. After I read that line, kind of a light bulb went off for me, and I went back through my code, some code I've written recently with all of these ideas in mind that theoretically is better than the code I used to write. And I could hardly do it to anything. Everything I was looking at required an and or an or. And so in the last few weeks, as I've been working harder at this, this quote has been really helpful. So let's look at an example. I stole this from a presentation that Justin Searles did a few weeks ago, but I just thought it was perfect at illustrating this. Who here writes JavaScript? Yeah, we all write JavaScript now. So jQuery. This is a really simple jQuery bit of code that when the page loads, binds to an element on the page, submits an AJAX request when that form is submitted, and then when it gets the result back, appends it to the page, right? Has anyone written code like this? Oh, come on. This week? I did. So again, really simple code, but let's take a look now at the responsibilities that this code has. So first, we have a page event. When the page loads, it's binding to that. Next, we have a user event. When the form submits, capture that and do some action. We have network I/O, because we're doing AJAX requests. We have user input, where we're taking the input from a form element on the page. We have network events, so we're listening for when our network I/O is finally successful. And then we have HTML templating. So 6 concerns that this small piece of code has. And these 6 concerns are basically 6 reasons to change, and also 6 reasons that this code could break. So when we write a test for this, I didn't have to write the test to know that this is why this code smells, but the test pretty clearly illustrates it simply by the number of concerns that the test has. So in this test, to do setup, I have to create all of the DOM elements. So I'm doing templating in my test, appending them to the page. I'm spying on AJAX because I don't actually in my test want to go over the network. I want to fake that out. I'm triggering my form element, so again, event handling. And then you can see the actual tests here that, in my opinion, these aren't as clean as I would like them to be. So this bit of code is obviously doing too much. Again, I'm not going to go into a ton of detail about the process I went through to refactor it, but here's what the end result looks like. So what I attempted to do was pull out all of the different concerns into separate classes whose primary responsibility could be that one concern. And so now this is a lot cleaner to look at and understand what's going on. So we have a collection of statuses. These examples are using Backbone. So collection is the thing that's responsible for synchronizing our data with the server. And then we have 2 views, one whose responsibility is to post the status, so take that user input and post it to the server, and one whose responsibility then is to append the statuses to the page. So without spending too much time on this example, you can see here's the collection and the model that back this. Again, this is using Backbone. Here's our code to actually post the status to the server. Again, really simple. It's easy to see with one quick glance that it binds. If you've done Backbone, I guess I should say this is pretty simple. It's easy to see that it binds to the submit event and calls our submit function here. It takes a user input, and then it does some action on the model. Notice there's no direct references to the model. I'll highlight that here in a second. And then our other view example here, we have a status list, whose responsibility is for just appending the status to the page. And so when that initializes, it listens for changes on the model. It calls this.collection.on. And whenever a new item is added to that collection, it calls its own add method, which appends the thing to the page. I don't have I'm not going to show the test for this code, but the tests end up being a lot simpler too. Because now instead of having to worry about all 6 of those other concerns, our tests only have to worry about one concern. Another tool that I found really helpful in listening for these code smells is actually documentation. I don't know that I want to ask this, but does anybody do inline code documentation? A few people. Who thinks it's a good idea? Who thinks it's a terrible idea? Awesome. More people think it's a terrible idea than a good idea. And I actually used to 100% agree with that. And I still am iffy on it. Like, I don't really care one way or the other. I've been trying it the last few weeks, and it's actually been really helpful. But when I joined GitHub, GitHub has this huge culture of documentation. To them, documentation is basically like their interface in Java. The documentation is where you define the contract for what this object does. And so I've been giving it, the old college try and experimenting with using documentation. And one thing that I found really helpful lately is actually documenting the responsibility and the dependencies for the code that I'm working with. So going back to our post status model a minute ago, at the very top of the code I've been playing around with, what is the single responsibility of this class? And then what are the dependencies that are required in order to instantiate it? And this has just been a really helpful practice for me in just being aware, because I know that once this is there and I commit it, somebody else is going to look at it. And if I have the word and or in my responsibility, then I need to spend more time working on this code. So, if you haven't tried inline documentation, I would highly recommend it. We don't do a lot within a method or like in the middle of a code block, but we do it a ton at the top of a class and at the top of a method. But yeah, I mean, if you haven't done it, try it. I know it's one of those things that's like kind of always preached, and it's either one way or the other, like you should do it or you should never do it. To wrap up this section, a quote from a book called Testdriven JavaScript Development. If you write bad unit tests, you might find that you gain none of the benefits and instead are stuck with a bunch of tests that are time-consuming and hard to maintain. And I think that's people that hate test-driven development. This is why, because they never actually saw the benefit from it. If we're trying to test, similar to the Goose quote earlier, if we're trying to test code that's poorly structured and we write bad tests, we're not really getting any value from those. So at some point it's just easier to delete the test directory and keep writing our code. So my only advice is pay attention to what your tests are telling you. If your tests are hard to write, then the code that they're testing is probably not right. It's not structured well. But try and listen to those at each step. Don't wait until you get to this point where you can't stand to work on the system anymore. So next I want to talk about slow tests, and specifically unit tests. Notice most of this time I've been talking about unit tests. If you read Growing Object-Oriented Systems, one of kind of their advice and something that I've been recognizing myself is I really only am finding value in two different types of tests. I have unit tests, low-level isolation tests, and then I have basically full end-to-end integration tests, whatever you want to call them, system tests. And those two things together are where I'm finding most of the value. And I don't really care about how slow my integration tests are because I'm not running them that often. I mean, I'm running them to make sure that the system still functions as a whole. But where I really find the value in test-driven development is unit tests and being able to run them 10, 20 times a minute to get immediate feedback on my system. So at GitHub, we know a lot about slow tests. I don't know, can you even see that? We have a lot of tests, so I wasn't sure if it would even fit on the screen. These are just our unit tests. There's 2,000 of them, and they take nearly 5 minutes to run. We also have like functional tests, integration tests, all of that. I think in total on my laptop, like our tests take like 15 minutes to run, which I mean, I guess some places that's probably not that bad, but for me it's horrible. I can't stand it. So slow tests have a lot of negative side effects. One, developers don't run them often. I found this as I've been working more and more on the GitHub code base. I just stop running the tests, at least while I'm developing. You waste time waiting for the tests. So every time I have to run, before I actually commit, I have to run all of those tests and sit there and wait and do something else, like check Twitter or I don't know, Hacker News, whatever's the latest and greatest source of developer news. Not only am I wasting my own time, I'm wasting other people's time. Has anyone seen this comic before? So this is about compiling, but the joke works just as well for running tests. And lastly, or I guess close to last, one of the other side effects is that failing changes get committed. So for me, when I'm working on the GitHub code base, I don't run all of the tests before I commit and push my changes up. I'll run just the tests related to what I changed and then push them up and wait for the continuous integration server to tell me if I broke something. And it's really unfortunate because then, one, I'm likely at that point holding other people up depending on which branch I've committed to and pushed. But I'm also getting, that's 15 minutes then that I have to wait to get feedback about if what I did broke something. And theoretically, by that point, I would be on to doing something more productive. But I'm kind of hesitant to dive into something else because I don't know if I'm done with the thing that I was just working on. And I think the biggest thing that we lose when we have slow tests is this rapid feedback cycle. So I said I run my tests 10 or 20 times a minute. And so what I do is in Ruby we have this thing called guard, which is a tool that will run certain tests depending on which files you change. And I'm kind of a compulsive command S hitter. Like I'll type a couple characters and then hit Command S while I stop and think. Then I'll type a couple more characters and then hit Command S. And so for me, I'm literally running my tests, maybe every 5 or 10 seconds. And I'm not always paying attention to the output of them, but at least for the files that I'm changing, I can see right away what they're telling me. And so I think this rapid feedback cycle is so important in helping give feedback about the design of our code. So let's look at a few reasons why our tests are slow and see if there's anything we can do to fix that. The first is that they're slow when you're interacting with slow components, like a database. So here's some more code from the GitHub code base. Back to our good email message test that we saw earlier. In the setup here, I need an issue. A GitHub issue is our, for those that haven't used it, is basically our issue tracker, our bug tracker. So in order to send this email message, I actually need an issue that is the thing that was created. And so if I call issue.make with a bang, with an exclamation point, what it actually does is it creates a new issue in the database. And when I run this test, I see something like this. So this test involves a lot more. There's more than just that one issue. There's a few other objects that get created that I'm not showing you. But it takes 3.5 seconds to run. Doesn't seem like a big deal until you have 2,000 and some tests, and all of them take 3.5 seconds to run. So how do we fix this? Well, it's actually pretty easy. We just don't save things to the database. So in our code, if I call make without an exclamation point, it just gives me back a new instance in memory that's not persisted. And so I don't have to worry about the overhead of making the database call. And then every once in a while I have to deal with annoying things like making it look like it's a persisted record. So I have to set the ID of the object if it's used in other places. But now I run this test, and it's 0.07 seconds. So I've just gotten a 50x speed increase by changing one line in my tests. I would love it if I could do this to the entire GitHub code base. Maybe I'll spend a few weeks trying to go through and find some of them. But the problem with doing it after the fact is that it's very tedious, and you have to worry about all the things that breaks. Whereas if you do this up front, if you don't save your records when you're writing the tests to begin with, you write your tests in a way that account for that. So that for me is a huge win. Avoid the database whenever you can, or anything else that's slow. The file system. I'll show an example here in a minute where we have to actually go to disk to a Git repo for a test to pass. We'll look at ways to avoid those. So the next thing is this idea of isolation testing. And this, for me, has kind of been a really important aspect of listening to my tests. If I'm not testing one single object, then likely it kind of tells me that I actually need to rethink how I'm writing this test and what this object is doing. So the great thing about isolation tests is they specify behavior and what exactly your object needs from its neighbors without actually having to call those. So let's look at an example of that. Here's another notification email, but instead this one's for a commit comment. I made a commit, pushed it to GitHub, and then somebody comes along and comments from the web interface. In order to do this, I had to have a commit, which means, so my first line, I have repository.make. So now we're going to the database, which we already talked about that we don't want to do. But the reason I had to do that is because of the next line. I have this read-only example repo. So we have a bunch of just like fixture repos in the GitHub code base that are, different scenarios that we might use in our tests. So I set that up. And then finally, I can pull a commit out of that. And then, and then the last two lines are the things I'm actually trying to test. So I have a comment that references that commit, and then I have a message, this email message that I'm trying to send. So those first three lines are the ones that bother me. Why do I need to care about a commit? Why does a commit actually have to exist on disk? Well, the tests fail if it doesn't, is the first reason. But it's really easy to actually mock that out. So I don't care where the commit comes from. I don't care if it came from the disk, or I don't care if it came from memory. So I'm going to stub it out. And basically what I want to do is try and make this object behave like a real commit, or at least the parts of commit that the code I'm testing cares about. So I say commit equals the stub. And in this test, I'm using the SHA method, the short ID, which is a shorter version of the SHA, the short message, and the full message. So I just create that as a stub. I pass that into my to my commit mention, or I create my commit mention, with that SHA. And then I also have to stub on my comment the commit method, because that's the one that says, okay, what's the commit that this comment is related to? So with those couple lines, I can run my test now, and I can see that I get a huge speed increase. So before, when I was actually creating a repository in memory, or in the database, and then initializing it on the file system and reading it, it was taking me half a second to run these tests, and now I'm down to less than half a second, or 5/100ths of a second, excuse me. So 10 times faster. So then another reason that tests can be slow is when they have to bootstrap heavy frameworks. We're going to talk more about this in a minute when we talk about kind of the smell of being coupled to a framework. But there's kind of been this pattern, at least in the Ruby world lately, of trying to avoid loading your framework in tests. There's no reason that we have to load all of, GitHub is a Rails app. There's no reason we have to load all of Rails to run the GitHub tests, because our application is not Rails. Our application is all the other logic that deals with repositories and the things that GitHub does. So, one example here, when I time my, this is for another part of the notification system. When I use the time method, or the time command on the command line, and run my tests, notice the difference in what Ruby's reporting the test time run and what the time command is actually saying. So my tests are really fast because I did all the things that we just talked about, and they're only running, it's 0.08 seconds. But the problem is that actually took 7 seconds to run because it had to bootstrap Ruby, and it had to bootstrap Rails, and all of the things that GitHub depends on. And so what a lot of people have started to do is create what they call a fast test suite, which is basically all the parts of their application that they can pull out from the framework and then only load those pieces. And again, this is the isolation testing that we just talked about. So one thing we've done so far is we've pulled out the web handler. I haven't done this yet with the email handler, but the web handler is now in the fast test suite because it doesn't depend on anything else that is in the system. And the couple dependencies that it does have here, we load them before the test runs. So now when we run the test, we're at 0.193 seconds. So we just went from 7 point some seconds to way less than a second. And so these things make a huge difference. This is part of that rapid feedback cycle. With my obsessive compulsive command save, I'm not going to get this feedback if my test takes 7 seconds to run because I'm already on to something else. So before we stop talking about slow tests, I want to talk about a few of the myths of slow tests. So Ruby's in this weird, or the Rails community at least, is kind of in this weird state where like it's been around for 5 years now, and so now all of a sudden we have all these apps that are legacy. When Rails came out, it was like, oh, we had testing built in, and we can just do whatever we don't have to think about design patterns or anything. Well, now we're paying the price for that. We have like the GitHub code base is now 4 years old, and there's a lot of problems with it. And so people are trying to figure out basically quick fixes for how can I make my tests fast. So one of them I've heard is our tests are slow because we have too many of them. And this one just kind of cracks me up because I've never been in an app, looked at an app where I thought that there were too many tests. I was talking with Justin Searles about this yesterday, and he says, okay, point to the tests that we don't need. And I think that's actually a really good response to that. Let's find the tests that we don't need and delete it then. But I don't think there are any of them. I think there's tests that are doing things wrong, like going to the database when it doesn't need to, or going to the file system, or testing too many layers in our stack. But that's a different problem than having too many tests. So one of the other myths is, well, to speed up our tests, all we need to do is parallelize them. So this is the idea that instead of running them in one process or one thread, we do multiple processes or multiple threads, or even across multiple machines. And while yes, I agree that that does help speed them up, I think you're just avoiding the real problem. The problem is that your tests are slow because your code is bad. And parallelizing them will alleviate some of that pain, but it doesn't actually solve the problem of writing bad code. And then lastly, specifically with the isolation testing, a lot of my coworkers are really hesitant about this idea of mocking and stubbing or using test doubles. Because I say, well, when I start to use test doubles, then I have no confidence that my code actually works. And I think the funny thing about this is that we're expecting to gain confidence about code that we're not actually testing. So the idea is that, okay, I'm going to write this test, and I don't want to stub out this component over there, because then I don't know that it actually works. Well, then we're not writing a unit test. We're writing an integration test or some other bigger system test. So I think the use of test doubles is almost essential when we're doing this pattern of isolated unit tests and then full system tests. Your full system test will tell you if things don't work, if objects don't obey this contract that they have. So my advice, pay attention to the speed of your tests as you write them. So before you commit, look at how fast your tests are, because the easiest time to change your test is actually when you're writing it. If you want to come back 6 months from now and try and speed up your entire test suite, it's just a daunting task. So be vigilant, pay attention. So then the last thing I want to talk about is kind of related to the speed of our framework, or the speed of our tests, excuse me, is being tightly coupled to a framework. So I've been noticing more and more that the code that I write that bothers me is the one that is specifically tied to some environment. So either it's it's inside of GitHub, it's a Rails app, so it's specifically tied to some component of Rails, usually Active Record. Or if it's a desktop application, it's tied to like Java Swing, or the .NET GUI APIs. So frameworks the problem with frameworks is that they encourage you to put all of your application in their sandbox. And it's nothing that they're intentionally doing. It's not like Rails is saying, hey, put your code here. It's just that it's giving us a sandbox to play in, and so we assume that we should play there. So like with Rails, actually I'll talk more about that in a second. So the problem with this is that it makes code difficult to test, to change, and to reuse. And I used to hear this argument and kind of ignore it and say, yeah, but I'm never really going to want my code to run in any other environment anyway. Why do I care? This is a Rails app. I'm not going to run it from the command line, or I'm not going to put a GUI in front, a desktop GUI on top of it. And I think that that's kind of missing the point of the argument. It's not that you want this code to be portable because you're going to change your application. It's that by separating it from these frameworks, we gain all of the other benefits that we've been talking about. We get better design, we get faster tests. So Rails, I can pick on that because I've been using it. When Rails came out in like 2005, 2006, it was, it was quite revolutionary. I'm sure we've all heard that whole story, blah, 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 we're sick of it. But I mean, it had the awesome thing of it would generate an application structure for you, right? So when I was doing Java at the time, I remember like I would spend 2 days setting up a new project. It was, well, I need my build scripts, I need my, my whole folder directory, I need to do this and do that. And Rails was just like, oh, this is awesome. I have a new app started, ready to go. And so one of the great things was, it creates your app directory structure for you and gives you these buckets to put things in. And I feel like the problem with that, as I've felt some of the pain, is that I'm now encouraged to put all of my code in one of these buckets. So Rails has, we have assets, controllers, helpers, mailers, models, and views. Anytime I write new code, first I'm asking myself, well, which of these buckets does it fit into? Generally the answer is it's a model. But then I also have this association with the models directory, like it needs to be an active record model, which is the ORM part of Rails. And so it ends up encouraging me to put all of my code within Rails boundaries. So this leads to probably one of the worst problems that Rails has right now, this idea of the God object. We have one object that basically depends on everything else in the entire system, and the entire system depends on it. So it's completely coupled. There's no way we can separate it. Or in other words, it's omniscient and omnipresent. So here's an example of this. Here's an active record model, the ORM part of Rails. And let's look at, let's think about, we talked about single responsibility principle earlier. Let's look at all of the things that this active record model does. One, it extends active record base, so by default it does persistence. Has validations, associations, enforces data integrity, so before we save a record to the database, or before we validate it, it sets a default state. Has miscellaneous concerns like auditing. Name scope is a method to query things by. We include these modules, which we have no idea what they do. There's some separate component that somehow affect the object that we're working with. And then lastly, we have our actual domain logic. So the thing that our application actually does, we put inside of these. So this ends up being quite a mess because this one object now has basically the responsibility of the entire system, which makes it difficult to change, makes it difficult to test, makes it slow to test. So most of your applications should work without a framework is kind of the premise that I've been going on lately. And this is really hard. It's really hard in Rails just because of this pattern that active record follows. And I was hoping to show an example of how we can work around that, at least in the Rails context, and I can't. With the way that active record's designed, it's impossible to pull out. I mean, there's strategies you can do to pull out parts of your application, but at some point you're always tied to active record. But there is a great example of this, again, coming from the Goose book. So in this book, you're working through this sample application, which is basically an auction sniper. So here's the things I want to bid on, and here's the price I'm willing to pay. Anytime somebody else bids on them, as long as it's under my price, go ahead and bid on it. And so when the application started, it was just a simple Java Swing app. Main window pops up. Okay, so we have one component. Well, then they start adding functionality to it, and everything goes within that main window. But basically, throughout the book, we work on refactoring with tests to pull things out. And you end up with something that looks like this diagram. I don't know how well you can see it. It was the biggest picture of it I could get. This circle right here is the swing part of the application. So that is the UI that the user interacts with, and it's almost no code at all. It's a little bit for maintaining a table view, launching the main window, but then here's the rest of the application. So it has no bindings to any framework. You can write really fast tests. You can write objects that are properly decoupled. So I highly recommend this book for that one reason, to figure out how to decouple things from your framework, if not for the million other reasons that I quoted it for. So unit tests help us isolate our code, reduce coupling to frameworks, which makes our tests faster. So one last thing before we leave. I want to quote from Bob Martin, who should be here today. Writing clean code requires the disciplined use of a myriad of little techniques applied through painstakingly acquired sense of cleanliness. This quote has kind of been my motto for the last year, because it's, as I've listened to like all of these great software people in our industry, kind of the sense that I got from them was that these are all the things they talk about are just easy. You know, if you just read the refactoring book and apply those 22 code smells, all of a sudden your code will be better. You know, if you follow these principles, if you follow test-driven development, you'll all of a sudden have this code that's in great shape with no problems. And what I like about this Bob Martin quote is pointing out the fact that it's, one, there's a ton of different ways, ton of different things we have to do in order to keep our code at a certain quality. And second, it's an extremely painstaking process. It takes everybody that's touching the code to go through this process to understand the principles that you're trying to apply, to understand the reasoning behind them. I know for me, I would often just apply techniques blindly and not understand why I needed to do it. So until you've experienced certain situations, then you understand why this technique is valid. So, and the last part, it's an acquired sense of cleanliness. You know, when I started 9 years ago, I had no idea what a clean system looked like. When Rails came out in 2006, I was really excited because it was a lot simpler than the way that I was writing Java applications. Well, it turns out the way I was writing Java applications, there was a reason for it, but I hadn't experienced the pain of that until I went through the Rails way of creating, you know, small, tightly coupled pieces. I've been picking on Rails a lot. I still actually love it. There's ways you can write good Rails code. I've just felt some pain from it. So to sum up, our code smells because we have a few objects doing too much work, which requires them to know about too many other objects. That's kind of been the theme of the things that I've learned in the last year. My problem is that my systems, I'm creating these huge components in my system that just try and do too much. If I break them down into smaller pieces, have them do fewer things with fewer dependencies, my life ends up being a lot easier. So a few references. I quoted from several books. I would recommend reading all of these. I've been trying to make my way through most of them. The Goose one, definitely read it cover to cover. It's amazing. Refactoring, it's been a while since I read it, but from what I remember, it had a lot of good ideas. X-unit test patterns, I actually haven't read yet, but as I was researching for this presentation, I kept coming across references to it. And so I read a few snippets, and it looked pretty amazing. And then lastly, Clean Code by Bob Martin. And then some of the ideas around fast tests. Someone mentioned, I think Chet this morning mentioned Corey Haynes. He's in the Ruby world, but he's doing some amazing stuff with helping people understand why we do the things that we do, apply these certain practices. He has a great video on fast tests, specifically in Rails, as does Gary Bernhardt. He goes through it with Python. So a couple of examples there. And that is it. Now we have some time for questions. Yeah?
You mentioned the challenge with the Rails model.
Yeah.
How do you do that? How do you get around that?
So the question is, you know, the challenges with active record models, how do you get around that? So there's a couple approaches you can take. Like one is that people have started to do or started to do a while ago is pull things out into modules. So Ruby has this idea of modules are basically methods that you can include into an object. They don't have any state, but it's kind of a way of doing multiple inheritance without the state part of it. So you'll see people pulling things out into modules. The little bit of code that I showed, a little bit of active record code that I showed, we were doing that. Let me go back to that real quick. So the who knows what these do, we have a bunch of modules in the GitHub code base, which are basically kind of some shared state or some shared behavior across a bunch of our models. The thing that bothers me about that approach is that you're still mixing behavior into this same object, and so this object now has those responsibilities. Like you're not encapsulating that in something else and deferring responsibility. You're making it this object's responsibility. So another method or another way of doing it is to actually create, pull all of your logic out into separate classes, and then pass your model as an argument. I can show you. Let me show you an example of what I mean for that. Oh, I'm supposed to take a break. Has that been up there for a while? Okay. I missed it. Won't let me close it. Well, I won't show you an example. I can't even get it back up. So the idea is basically you create an object that has all of your whatever your concern is, you have that concern in it. And then on your active record model, you still have that same method, but then you pass in the active record model as an argument to that object that then does all those things. So then you can test that logic separately, and you can even have a fast test because it doesn't really care what you pass in as an argument. It doesn't care that's an active record object, as long as it behaves the same. Ultimately, I think what the answer is to kill the active record pattern. So the active record is one of the design patterns in the Gang of Four book that basically is this rich domain object that can talk to the database even though you don't know it's talking to the database. And when Martin Fowler, he gave the keynote at RailsConf 2006, which was the first one. And what he said there was he actually thought the active record pattern was a terrible design pattern until he saw it applied in Rails. I hope what he would say today is that he still thinks the active record pattern is a terrible pattern. Because I mean, it just encourages you to have these big, huge, crazy, rich objects that do too much. So I think what the answer is going to be is to move away from the active record pattern into the repository pattern, it's called. And this is, I think, how like Hibernate and all of those do it, where you basically have one class whose responsibility is persistence, and that just returns another class who is actually your domain object. So, and in the Ruby world, there's Data Mapper 2 is an effort to move to that. And Searles and I were talking yesterday. I don't know if that'll ever be successful, just because it's going to be hard to get people to adopt it. Good question. Sorry, that was a really long answer. Other questions? I think we have a little while, so we have 8 minutes, I'm told. Yeah, in the back.
I think you asked a question about JavaScript. Do you have any suggestion on any tools that can be used for writing units for JavaScript?
Writing unit tests for JavaScript? Yeah, there's actually some great JavaScript testing tools. The example I showed was in Jasmine, which is this behavior-driven flavor, like RSpec and Ruby. And that's my favorite. That's the one I've been using. But there's also QUnit is what the jQuery code base is built on. There's YUI, I guess, has a great testing framework. You don't actually have to use YUI to use it. So like JavaScript is actually really easy to write tests for. Most people think it's the opposite, but what I found is the reason it's hard to test, actually get my talk in Italy last week was on this. The reason that JavaScript's hard to test is because we structure it really poorly. We do that jQuery example that I put up. But if we start to refactor our JavaScript into like good design patterns that we apply in other languages, it turns out to be really easy to test. So that testing or JavaScript, hold on, what was the book called? Test-driven JavaScript development book is okay. I would recommend at least looking at that. But I don't know of any other great resources to get started. Yeah.
So, have you noticed any correlation with any kind of code metrics or anything with code smells? I mean, is there a way that if you have this huge code base, you want to take a look at it from a 10,000 foot view?
Yeah. So the question is, like, is there any correlation to metrics? I honestly have not done a lot with metrics. I wish I had a good excuse, except that I'm kind of more of a like touchy-feely guy and not a numbers guy. So like I try and go more off of intuition. There's a paper on, I don't remember what it's called. I read it when I was researching for this. There's a paper that's basically like test-driven development and code smells. That they actually do a comparison of like, do code smells map one-to-one to metrics? And kind of what they found in their study was there's some correlation, but sometimes you'll have a smell that doesn't necessarily show up in the metrics, and sometimes you'll have metrics that indicate a problem where your intuition doesn't really tell you there is one. So I mean, I don't know if anyone else has done more with metrics. That, like, Zach, do you have anything to add to that, or? No, okay. Sorry to put you on the spot. Yeah, I mean, that's all I know. So check out that paper. Any other questions? All right. Thank you very much.